This video is going to be about stretching graphs vertically. So when do we stretch a graph vertically? Well, if you have a function f of x and we consider its graph, so let's draw a typical graph. Then we may want to multiply that function by a number, and we have to see what's the result of multiplying that function by a number. We get a new function, so we get a new graph. So for example, if you take the number k to be 2, we multiply that by f of x, and this is the graph of f of x. What's the new function look like? Well, all the values are now twice as big as they were before. So if a value was, say, 1, 2, 3, so that height is 3, then now it's 2 times as large, so it goes up to 6. Suppose the value of f of x were 0, like right here and right here and right here. These are the zeros. Well, if I take f of x and I multiply it by 2, I still get 0. So for that, in that case, nothing's changed. What if I take the value of f and it's in a negative number? For example, here the value of f is negative 3. Well, 2 times negative 3 is negative 6. So the new value is down here. Okay, so let's try to draw the new graph. Well, it goes through these points. This is the graph of 2 times f of x. Okay, so look what's happened. The original graph was f of x. It was the graph of the graph is given by the white, and we stretched by multiplying by 2. We stretched to get the new graph, which is the graph of 2 times f of x. So all the y values have been magnified by 2. Of course, if the y value was a negative y value, it's become more negative. If it was a positive y value, it's become more positive. And the 0 values haven't changed at all. So that's an example of stretching graphs. Now, that's if the number 2, in this case, or the number k is positive. So this is what happens when k is positive. We can, in fact, write this down. The graph of, this is the general principle, k times f of x is simply the graph of f of x stretched in the vertical direction by a factor of k. Okay. What in this case we stretch by a factor of 2. What if we were to take a number that was less than 1? So now let's look at a different example. Let's take the example of 1/2 times f of x. What does the graph of that look like? Well, instead of taking each individual value and multiplying by 2, doubling it, we're going to take half of that value. So for example, if the value had been 3, now the value is 1.5. Or if the value had been minus 3, now the value is minus 1.5. Or if the value had been 0. So if f of x had been 0, then 1/2 0 is 0, so it's still the same. If the value had been minus 3, it's now minus 1.5. So now we can see that the new graph, it looks like this. Okay. So the graph of 1/2 f of x is exactly this purple. So stretching by a factor of 1/2 makes the graph closer to the x-axis. It sort of shrinks it. And it shrinks it by a factor of 2, but that's the same as stretching by 1/2. Okay, so now that's what happens when you multiply the function by either a positive number less than 1 or a positive number bigger than 1. You get either stretching or shrinking, where stretching can be thought of as shrinking by a factor less than 1. Okay, what else can we do? We can also multiply f of x by a negative number. What happens if k is actually negative? For example, -2. Well, let's draw a new graph, because this one's getting a little bit busy. So here I have a function, f of x, that's going to be described by this particular graph. There's my graph. I'll call it f of x again. My x variable is the independent variable. And now I'd like to figure out, what do I do if I say have -2 times f of x? What does the graph of -2f of x look like? Well, the first step is to ignore the minus sign and think about, what does 2 times f of x look like? Well, we saw before that it stretches it by a factor of 2 in the vertical direction. So the graph of the sketch of the graph of 2 times f of x looks like this. All we're interested in here is sort of a sketch. So it doesn't have to be too precise. Every value is twice what it used to be. But now let's consider what happens with this minus sign. The minus sign makes every value the negative of what it was before. So if it were a positive value, now it becomes a negative value. So this value comes down here. This one goes up there. What happens to the 0 value? Well, if I put a -0, it's still 0. So these are the same. If I took this value, the negative of that is up here. So everything gets flipped across the x-axis. So in general, minus sign means flip across, oops, I think I spelled across wrong, across x-axis. So what does the new graph look like? Instead of going up, it goes down, and it goes down here, and it goes up. So what you should imagine is that you have a barbecue spit, or maybe a skewer, and you think of this red has been put on the skewer or on the spit, and then you rotate the spit, and the red flips over down to the blue. And of course the red here flips up to this blue. So everything flips across the x-axis. So that's what this minus sign does. So again, the graph of the original function was f of x, that's the white. Multiplying by 2 stretches it vertically in the y direction, making certain positive values more positive and negative values more negative. And then multiplying by 2, adding the minus sign, flips across the axis. So this resulting blue curve is the graph of -2 f of x. Okay, so that's what we needed to accomplish.